In only about 2 years, JetZero, the company behind this plane, planned to have it flying. Not a scale version of it, no, an actual full-size prototype, and it looks like they now have both the partners and the money they need to actually make that happen. But why? And also, if big names like Boeing, Airbus, and Embraer and other established aircraft manufacturers aren't building something like this, then why would a startup stand a better chance of making it work? And also, who really is JetZero?
JetZero.
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 Now, it's been a while since I made a video about blended wing body aircraft designs, which is what this aircraft is. Blended wing bodies aren't as extreme as pure flying wings because they still have a fuselage, but this fuselage still generates a considerable amount of lift and can also be aerodynamically stable, which isn't necessarily the case for flying wings. But the first question that we need to answer here is, why bother with this design at all? Why would an airline prefer a blended wing body over a tube and wing airliner that we all know and love? Well, the quick answer is efficiency. You see, the body profile of a platform like this can bring gains as high as 30% in aerodynamic efficiency alone, and some companies claim that they could do even more than that now. It is important to understand just how enormous that 30% would be usually. By far the biggest efficiency gains we've seen in modern airliners recently has come from new engines, not from aerodynamic improvements. When Boeing and Airbus, for example, put new engines on the 737 and the Airbus A320 to create the 73, the MAX and the A320neo, they improved their efficiency by around 14 to 15%, which was a really big deal. By comparison, recent airframe-related gains are much less impressive. If you look at, for example, the brand new oil composite Boeing 787 with Rolls-Royce Trent 1000 engines, it's only around 2 to 3% more efficient than the Airbus A330neo, who sport nearly identical Trent 7000 engines, but with an aluminum fuselage based on the much older Airbus A300 design. Now, these numbers can vary depending on the route length and passenger count, but I think you get the idea. The engines have always been a much more promising avenue for efficiency improvement, but even the 14 to 15% improvement from the 737 MAX and the A320neo engines would only represent half of the improvement that a blended wing body design is promising. So that's why there are quite a few commercial and military operators that are really interested in designs like this. But here you might also ask, if blended wing body designs are so good, then why aren't all airliners built this way already? What's the catch? Well, as it turns out, there are quite a few of them to choose from. An obvious one has to do with airports, specifically with airport gates. At the moment, those are designed for the relatively long and narrow airliners that we know today. But blended wing bodies will be shorter from the rear and wider, which could put them beyond the size of typical airport gates for single-aisle aircraft. Now, this could be overcome by giving these planes folding wings, which has already been looked at by JetZero, but probably won't be a feature at least on their prototype. The next problem is pressurization. Conventional airliners have had tube-shaped fuselage even before pressurization was a thing, since that shape is both strong and lightweight, but as it turns out, a tube is also ideal when we want to turn it into a pressure vessel. It's no coincidence that oxygen or nitrogen gas cylinders or fire extinguishers usually have this shape as well, but with something like a blended wing body, the passenger cabinet and cockpits have a much more irregular complex shape, and pressurizing that would therefore historically require more material to allow the fuser structure to resist the internal forces and retain its form, and also to avoid developing cracks over time from metal fatigue. Fortunately, new carbon composite materials are now helping a lot with this. When made and shaped properly, composites are a lot less prone to pressurization cycle fatigue than the aluminum alloy that most airlines are made of, and therefore allows for more complex shapes to be made relatively easy. But these complex shapes also create a different problem. When the plane's fuselage is just a tube, a manufacturer can easily build differently sized versions of it, basically by just adding slices of fuselage in front and behind the wing. Well, there is of course a little bit more to that, like extra emergency exits, but that's also relatively straightforward. That possibility to vary sizes is crucial because when airlines add a new aircraft type to their fleet, they usually also want a few different sizes in order to fit different roles and routes. And since those variants are more or less exactly the same aircraft, just differently sized, this then eases training for pilots and engineers and makes crew swaps easier when needed. But how do you accomplish any kind of variability in size with a blended wing body, where each size version requires its own setup, jigs, and molds to shape the composite structure? That would mean different production and assembly lines for each new variant, which would complicate manufacturing and CR costs way higher. Well, initially the cost to make these composites would be high anyway, but this is where the Zero's plans for their blended wing body design starts to get really interesting. The company has issued a patent numbered US 6,708,924 B2 if you want to look it up, and that patent addresses a number of blended wing body challenges. You see, even though the fuselage and wings will have nice smooth lines when finished, the plane is actually put together like a Lego toy made out of bricks. The pattern shows that the passenger cabin will be made out of rectangular sections running front to rear, with each section having a door at the front. So to make aircraft of different sizes, sections like these could then be added or removed or swapped out for different ones, so to vary. JetZero would simply make the necessary sections separately and then bond them together in the right combination for the desired size. This method also helps address another issue with blended wing body concepts, which is the number and placement of emergency exits. In an emergency, we want people to be able to evacuate the aircraft safely, even if half of the available exits are blocked, and because of that, available exits should be spread out and they should be placed as evenly across the cabin as possible. Okay, now here the doors are towards the front, but the width of the cabin means that even those seated in the back aren't too far away from an exit. Now, I should add here that patent drawings must always be taken with a little bit of a grain of salt, because they're designed to secure a process without giving away anything more than absolutely necessary, which can make them quite misleading. But in this case, we at least get an idea about how such an aircraft could be feasible to produce. Again, thanks to modern composites, but I still haven't talked about JetZero, the company, and why we should believe that they can actually build this. Now again, if we look at JetZero, what is it that speaks for this company being successful in creating the first ever commercially viable wing body design? Well, first of all, even though this is obviously a startup, their people are not new to the industry. Mark Page, JetZero's chief technology officer and one of the two founders, has worked in aircraft design roles for both Boeing and Douglas. Before that, he was actually part of a joint project between McDonnell Douglas and NASA for the development of a blended wing body aircraft already back in the 1990s. The other co-founder and CEO, Tom O'Leary, has worked for Ford and Tesla, among others, and other key people in the company have had engineering and other positions in Boeing, Airbus, and Embraer, Bombardier, Safran. Their expertise also includes people with experience within airlines like Delta and Qatar Airways, and even from the lesser AerCap. So that's a broad range of people with aviation backgrounds, which we don't always see at ambitious new companies like this. Yet Zero has also announced partnerships with Pratt & Whitney for its engines, which I'll get back to shortly, as well as Collins Aerospace for the engine integration for other key systems. They will work with companies like BA Systems, Safran, Varley's, and other well-known names in the industry, which will be absolutely crucial for its success. Now, all of this talent and partners obviously need funding to put together on actually flying aircraft. And as I mentioned briefly in a recent video, JetZero has actually secured a contract worth $235 million from the US Air Force to construct this full-scale demonstrator aircraft. The reason the Air Force is interested is because, as a sign, like this could be useful either to transport people and materials or as a tanker for air refueling, which the Air Force refers to as the next generation air refueling system and gas. For the military, a blended wing body has an added advantage as well because it has a relatively small radar cross-section since its underside has few inside corners and its engines sit above the actual fuselage. But whilst $235 million is a decent sum of money, it really isn't close to what's needed to design and develop a new airliner, especially such an unusual one. According to John Ostro in the Air Current, who are keeping track on this project and who you should really check out if you haven't already yet, Zero will need $7 to $10 billion to develop a production version of this aircraft. Now, JetZero does have more funding from other investors, including some of its industrial partners and from airlines like United and Alaska Airlines, but for now, their total funding, including the Air Force's contract, sits at just around $300 million. But I did say earlier that this aircraft was going to get built, so how will they do that with only a fraction of the needed budget? Well, as you might have noticed, I early referred to that first aircraft as a demonstrator, which was a bit of a clue. You see, the first aircraft that companies like Boeing and Airbus make when they launch something new may undergo small changes during development and certification, but they are largely built to a production specification. So that means that many of these development jets actually end up joining airline fleets when the testing is done. But by contrast, JetZero demonstrator will be an old-fashioned prototype similar to what Boeing did in the 1950s with its 367-80. Benaz just did -80, which was a prototype for the mighty 707. Incidentally, Boeing's first customer for that old demonstrator was the US Air Force because it was also the prototype for the KC-135 tanker, and now the JetZero demonstrator could become the basis for the Air Force's next tanker, which has a nice symmetry to it. JetZero has already also built a simple cabin mock-up to show its potential customers what this unusual configuration will feel like. There are multiple cabin sections, so look like side by side, single aisle cabin soup open up in the front, and I am really looking forward to see how that works for those sitting.